Good morning, once again to everyone. So we are now on our first webinar of the year 2026. This is part of the webinar series of our cost action, BeSafeBeeHoney. And today for this first webinar, we have Soraia Santos. She's a PhD student from the University of Coimbra. She is also part of the B team from the University of Coimbra, who has participated in several studies nationally, internationally, regarding the part of the beekeeping field, which I think Soraia will further explain this. Please, if you have any questions, leave it on the chat. And at the end of the presentation, we'll have 50 minutes of discussion regarding these questions. So, Soraia, first of all, thank you so much for being here and welcome.
Thank you.
The topic that Soraia will present will be safe from bees predator, Vespa volutini nigrithorax. I don't know if I say it well, but I think you will
Okay.
say it afterwards. So yeah, the floor is yours. So you may begin the presentation. Thank you.
Thank you very much, Marta. So, good morning, everyone. As Marta said, my name is Soraia Santos. I'm a PhD student from University of Coimbra. I'm working with the B team from my university, and today I would like to share with you part of my PhD project. When we think about bees, we often think about honey, but bees give us much more than that. They support ecosystems, agriculture, food security, and face several pressures. I'm going to explore one in particular, a new predator in Europe, America, Japan. So my presentation is BeSafe from bees predator, Vespa velutina nigrithorax, or yellow-legged hornet. But first, let's see what is an invasive species. An invasive species is a species that arrives in a new territory, usually brought there by humans, directly or not, and establishes itself, multiplying and causing several negative impacts. These species can be insects, plants, fungi, birds, whatever. So we can distinguish three essential stages for a species become invasive. First, the exotic species is introduced. Second, the naturalization occurs when environmental barriers no longer prevent individuals from surviving and regular reproduction is exceeded, which leads to an uncontrolled increase in population. So there is an invasion. These silent invasions can affect health, economy. Actually, it can cost millions to the global economy every year. But the highest cost is not financial, it is ecological. We have loss of biodiversity, extinction of native species, alteration of ecosystems. And the cost to the bees is no less significant. But before we look at the real impact that this harmful species has on bees, let's learn a little bit more how it has spread and what it is, this predator. So nowadays, a container can travel from Asia to Europe in under 30 days, more or less. And inside there may be thousands of these invisible insects. And this species needs only this opportunity to become exotic and just one more step to become invaders. And this brings us to our next point. How did the yellow-legged hornet end up in Europe? And well, this hornet is naturally distributed in Southeast Asia, but in 2004 was accidentally introduced in France for the first time and has rapidly spread for other countries around Europe. But how we have reached this point, how that we let this happen, there are several factors contributing to this silent invasion. So besides the political issues, the damage usually comes later, and also we don't know when they appear. The news don't report this on the day that they arrive. So besides that, we also have misidentification of the species, and this is really important. For example, on your left, you have a new report from a new in Ireland that report an invasive hornet that was detected for the first time, but the image that appears is about the European hornet, so it's not the yellow-legged hornet, the invasive one. And on your right side, you have another new, this one from Portugal, where they're saying that a small region eliminate 90 nests of the yellow-legged hornet, but shows an image of Vespa mandarina. And this is not correct, because if the information is inaccurate, how will the citizens be able to act? So the first part that I would like to clear about is how to distinguish this hornet from the other ones. And for that, we can focus on three essential parts: the black thorax, the legs with yellow tips, and the single orange abdominal band. Besides that, it's also important to distinguish the nests, and they are also slightly different. So for cravo hornets, that is the European one, they seek to build their nests in holes in trees, while yellow-legged hornets are not as selective and can easily be found in trees, on the ground, under the roof tiles, etc. Besides that, we also have differences in the entrance. So on Vespa velutina, the entrance is in the side of the nest, while for the European one is on the bottom. The successful invasion is also attributed to their reproductivity. So after winter, the life cycle about these hornets starts on the winter, on the end of the winter, sorry, when a fertilized queen establishes its colony by building a primary nest in which female workers are produced. During the summer season, the colony will build a secondary nest in which will develop. At the end of the summer, new queens are produced and fertilized by the males before hibernating over winter again, while the rest of the colony dies. As an insect, the yellow-legged hornet lives in large colonies divided into castes. So we have the queen, female workers, and males. And here you also can see the difference between the different stages on the development. So now that we know a little bit more about this predator, let's see the real impact on honeybees. First, one of the major impacts is the result of the hornet's diet. So in 2024, a study identified around 1,000 species of insects preyed upon by these hornets, showing a huge numbers. However, honeybees are an easy prey in apiaries, becoming their main food sources. But we can put this in a real context. So we know that an Asian hornet nest needs around 14 kilograms of insects per season. And if the nest is closed in an apiary, it can be a serious problem. To put it simply, so each hive has around 40,000 bees, that is around 4 kilograms. So we know that to fulfill a nest per entire season, we need almost 4 colonies, 3 colonies and a half. If we put more than one nest near an apiary, everything is intensified. So this is a big and direct impact on mortality. Predatory activity increase in summer and autumn and not in spring, in contrary to popular belief. And this is also very important because they can collect the nectar in the summer, but when they need the pollen and to start storage for the autumn and winter and start preparing the colony for in autumn for the winter, the hornet's pressure in front of the beehives is too high. They hunt the bees not only at the entrance but also in the flight. So they can't forager, and if they do, they may not return, and the colony become really weaker. So besides that, we also have is in this part of the season that the colony is already fighting against a parasite, the varroa mite. So these two stressors become hard for the colony to survive. Another impact, or indirect one, this predator behavior can have a different impact. So we already know that yellow-legged hornets can carry pathogens like viruses and fungi that are common in pollinators. Although little is known about this subject, we do know that they can be secondary hosts or reservoirs. And indeed, it is possible that we are dealing with another way of disease spread. So maybe we are seeing a vector of disease transmission. Well, I don't know if the quality of the video, but I think so. I think it's good. So on this video is about the invasion of another hornet in Asia that is going inside to a beehive of Apis cerana, also another honeybee species. These honeybees and hornets have been living together for thousands of years, and this has led to them to adapting to live it together, and bees develop this survival strategy, the heat ball technique, a way to kill a hornet by suffocating it. But unfortunately, European bees haven't shown this behavior yet because it's too recent. But we hope that they could achieve this behavior. So if they cannot protect themselves, our bees at least, we need to do something to help them. We need to do something to minimize all these impacts. So yeah, now just to finish the video, here you can see the heat ball. And the result. That's it. We hope one day our honeybees can do this. So yeah. Before moving on to control methods, I would like to understand what you already know, your opinion about this subject. So therefore, I have 3 questions that I would like you to answer. To do so, please access this QR code or the website, and then or the website and the code that is above. I will share the other part with the QR code. So please join. Yeah, I'm seeing that people are already answering. The question is, what is the most commonly used technique in control? This is anonymous, so you can answer everything you want, but it's okay. Okay, I think the 11 person is me, maybe. Okay, just will wait a little bit more. There are still people that are going to access. So again, the question is, what is the most commonly used technique in control right now? Some more answers I think I need. Okay, so pesticides and mechanical removal are the main ones. And we'll moving on. So the answer of this question is, it not appears, sorry. So it's pesticides. Mechanical removal sometimes is too hard to remove the nest. So I think that pesticides is the one that has been the most used. Next. So it will appear another question, I believe. Please tell me if not. And the question is, do you think that the techniques we currently use are sufficient to control the species? This was an easy question. "13 answers, 14. But yeah, I believe that we all agree that no, what we are doing is not enough. One person said yes right now, but I agree with most of you. I don't believe that what we are doing is enough to control these invasive species. So I don't know if the two remaining people still want to answer. If don't, I can move on. Okay, I will move on. Last question. Which technique do you think should be used most often based on what you already know about the hornet? You can choose more than one here. I put some different techniques, and I really would like to know your opinion. What should be what would be more effective to eliminate not only the nests, but also the species itself? This question is for me to understand for my future on the PhD. This will help me also to develop my work. Okay, very interesting. Again, you can choose more than one answer. I think at least three, and three choices. And we have very interesting answers. Okay. More 7 people miss. So I will wait a little bit more for you to think about it. No more answers? There are still people that didn't submit their answers. 7. I will save these answers and I will work on them later. Okay, so I think I will finish my questionnaire, my quiz. Yeah, I think that's it. Thank you for your answers. So let's talk about a little bit about this part. I will left pesticide injection for the end because I will talk in my presentation. The fire burning the nests. Well, it has been hard because of the fire Usually they are on trees, and we need a lot of people. The firefighters need a lot of equipment and is not very safe. Traps helps, and I will also talk about a little bit on traps, but actually traps only works and only is effective in early spring. Introduction of natural predators is also very interesting, but we know that maybe we need to be careful with the kind of predators that we are using. Ecologically can give us serious problems in the future. Genetic manipulation for sterilization. Well, this is an interesting topic also. So this was made in some flies, not in hornets that I know, at least, but maybe is an answer for the future. And parasites and pathogens is also a very interesting. And I'm really happy for your answers here. Was the winner answer, because we also will talk about that a little bit on my presentation. So I will carry on. Thank you again for sharing your opinion. And yeah, so thank you once again. So about control methods, we saw traps, detection. So traps is usually used for prevention and can be handcraft and commercial. We can active eliminate the nests, and for that we need the techniques that we talked about. The chemicals, we can use fire, CO2 also. So let's see about the prevention. For the prevention, by setting commercial or homemade selective traps, taking into account the hornet's life cycle, so we can use early spring and fall to capture the founders and prevent another nest from forming the our area. So on spring, we have the queens that are fertilized. So if we catch one hornet in our trap, is less one nest that we'll have around us. Our group has been working on the control of this species for a while, and we develop this video. Is in Portuguese, but I believe you can understand within the image, and explains how to do your own selective trap. And you can use again this QR code to access this video on your Instagram. I would like to also highlight that it's important that these traps being selective for the pollinators could escape and keep the hornets inside. For the active elimination, as I said, first we need to detect the nests, and this detection can be passive if the citizens report to authorities, or can be active if you use techniques such as radio telemetry, radar, triangulation, but these techniques usually are a little bit expensive, and we need specialized people to perform it. For the nest elimination, as we said, the chemical, fire, and CO2. Today we are talking more about the chemical, the injection of pesticides. So we already answered this question, is this enough? I agree with you, I don't think this is enough. Despite its growing impact, control strategies remain largely ineffective. So
Soraia,
this is
sorry, you're stuck in the same part of the Mentimeter page for 5 minutes.
Okay.
Same here, Arthur. Yes,
Please,
I was saying
please
the same
correct it.
thing. Yeah.
I thought that I was sharing the right one, so I'm sorry. I will try it again.
Sorry. Thank you very much.
No, thank you, Arthur. And now? No.
No, we're still on the same, Soraia.
I don't understand why. Well, I will just close the other one. And now, start sharing again. This one. Okay, and I will put on I was here. Can you see it?
Yes, now it's on the active elimination or control methods now.
Control methods. So I will repeat again for you to see the image. It's okay. Thank you very much. And I'm sorry. So for the control methods, we have prevention, as I said, traps, and active elimination by detecting the nests. So for the traps, one earlier. So for the prevention, we can use the commercial and homemade selective traps, taking into account the hornet's life cycle, as I said, the spring, mainly for capture the founders and prevent another nest from forming in our area. So here is the QR code that I was talking about to access this video. As I said, our group has been working on the control of this predator for a while, and we developed this video. It is in Portuguese, as I said, but I think you can understand. Yeah, so I will moving. For active elimination, as I said also, so we have passive and active. Passive when citizens report to authorities the location of the nests, and active when we perform techniques like triangulation, radio telemetry, or radar to detect it. But usually we need specialized people, and these techniques can be sometimes expensive. So today we will talk about the chemical way to eliminate the nests, but we also have another options like the fire, the burning that we talk about, and CO2. So we already answered this, is not enough what we are doing. So despite these growing impacts, control strategies remain largely ineffective. This isn't because people haven't tried, but because they don't have the basic information about the species itself, as well as standardized protocols to controlling it. So we know how it behaves in the field, but we don't know much about what happens inside the hornet at the molecular, immune, and physiological levels. We do not yet understand the mechanisms that regulate the yellow-legged hornet's response to stressors, such as pesticides and pathogens. And without this information, we are fighting blindly. This project proposes exactly that, understanding how, why, and in what ways Vespa velutina reacts to different stressors, and only then we can develop effective, conscious, and more selective control measures. So for the experiments, we need to collect the samples, the adult and forager yellow-legged hornets. For that, we need to contact authorities to have the location of untreated nests. And this is not an easy part. We have some specificities that need to be followed. The nest should be at least 40 centimeters diameter, lower than 6 meters, should be active, and we also should check the weather. It is not advisable to collect on humid or rainy days because it will increase the mortality on laboratory later. And also check the safety of people and animals in the surrounding area. If everything is okay, we will capture the hornets at the nest entrance and put them in the containers for transport under cold conditions. In laboratory, when we are preparing the experiments, we need to select the pesticides. Currently, the most commonly used strategy in Portugal to eliminate a nest of Vespa velutina is the injection of pesticides. However, although there is a list of authorized pesticides to inactivate the nests, before our group starting to work on this subject, there were no scientific studies on the effectiveness of these pesticides and the environmental damage that they can cause. So we taking into account when we were choosing the pesticide, we taking into account if it's authorized in Portugal or not, which one is the most used, if the products have potential to remain medium long term in the market, but also their toxicity for other insects, mainly bees. We also consider potential predators or animals that may come into contact with the treated nests, such as mammals, and their degradation time. And this is essential. The choice of the pesticide can be crucial to optimizing the efficiency of our fight. Our group has already tested for pesticides, so pyrethroids, an insecticide derived from flowers, which degrade quickly when exposed to the sunlight. Pyrethroids, like cypermethrin, which is very similar with the previous one, but synthetically formulated to have a longer persistence time. Spinoside, a biocide that works in a similar way to a neonicotinoid, and acetamiprid, a neonicotinoid that has a slower degradation time comparing with the remaining ones. Currently, in this project, we are also testing lambda-cyhalothrin that belongs to pyrethroids group, but as a property that enhances its ability to penetrate the tissues. After selecting the pesticides, we conduct the CUTE tests. So these tests are based on OECD protocols, and for the adult hornets, we can administrate in two ways, so contact and oral. For contact exposure, we start anesthetizing them with a freezer, and then we put a drop of the solution on the top of the hornet's thorax. For oral exposure, 3 hours earlier, we need to remove the feeder and clean the cages if is needed for a fasting period. Only then we can expose them using a micropipette, and then we replace the feeder for food availability during all the 96 hours of the experiment. We check the mortality and behavior every 24 hours. These were the results that we obtained for contact. Each graph corresponds to one of the pesticides at different concentrations of active substance. The data proves that acetamiprid was the most effective, with a peak mortality at 24 hours. And it's also important to note that much lower concentrations were used for acetamiprid than the remaining formulations. So we have high mortality rates, making it the most toxic compound. The data for lambda-cyhalothrin are still being evaluated here. We already published this data. Feel free to check the paper. Again, a QR code to access it. For the oral exposure, it is clear that concentration here was considerably lower when we compare with the contact, and acetamiprid was again undoubtedly the most effective. However, we detect something very interesting at a practical level, and that is essential for transposing what we are doing in laboratory for the field. It was evident from the laboratory tests in which the hornet had been fasting for 3 hours that they exhibited an avoidance behavior, refusing to eat the mixture. So probably in practice, they would not ingest the pesticide and die only by contact exposure. So the effectiveness of this formulation maybe is not the one that we expect in the beginning. And we know that cypermethrin and pyrethroids are used extensively around several municipalities around Europe, including Portugal. So maybe we need to see if it's the right pesticide to apply. And I really would like to think about one question at home. what you think about these low concentrations of acetamiprid. I know that is a neonicotinoid, but the concentrations are much lower when we compare with the remaining ones, and they don't feel it like they feel the cypermethrin, for example. These data are also published, so you can see on. I also put here the QR code. Feel free to check it. Another stressor that we will expose the hornets is the pathogens. Sorry. It has now been proven that hornets have pathogens that are normally associated to pollinators, such as bees. However, it is unknown the effects on hornets, and this is important because does it make the hornet a vector of disease transmission that I previously referred? To try to better understand how this interaction works, we will artificially infect the hornets with two pathogens, Nosema that cause gastrointestinal problems, and deformed wing virus, virus that cause wing deformities, as the name suggests. These two pathogens are common in honeybees and bumblebees, for example. The experiment will be very similar with the previous one with the pesticides, but with longer duration, because of the incubation time. And because in the real world, hornets don't encounter one stress factor at a time, the question is, how do they react when they are exposed to a pathogen and a pesticide at the same time? And can we use this interaction as an advantage for their control? To better understand these responses, we will also look at the expression of key enzymes at the transcriptome level responsible for immune response. For example, the cytochrome P450 is an enzyme linked to the processing of xenobiotics, like pesticides. So changes in how much of this enzyme is expressed can be a direct response to pesticides in the hornet's body. In addition, we will compare conserved domains between taxonomically close species, and this will allow us to predict sensitivity, compare species, and maybe minimize the negative impacts on native pollinators. In summary, with the multidisciplinary approach, where we are using ecotoxicology, microbiology, genetics, we can move towards a more targeted control strategy, evidence-based, ecologically responsible, and with less risk to pollinators. In other words, we can stop using generalist methods and start using science to act with precision. Thank you for your attention. Don't forget that invasions are silent, science cannot be. And I would like to know if you have. Thank you very much once again.
Soraia, thank you so much for your presentation. Let me check here on the chat first if we have any questions. So we have one from Cristina Pereira that says, insect sterilization is a biotechnical process based on chemical or physical radiation sterilization. So usually it is not included in genetic manipulation, I think. I don't know if you want to.
Yeah, so I know I put it here, but I know, but there is other techniques like using CRISPR-Cas9 to do it, for example. But yeah, usually the most used common for even for flies is correct, is the radiation.
Okay, so yeah, sorry, do you want
No,
to?
it's okay. But
Okay.
I think I answered it.
So we have Midat that said, congratulations, nice research, well designed and useful results. So for now, we don't have any more questions on the chat, but I would like to open questions if anyone wants to add something, any comments or question. Please raise your hand. So we have Muhammad. Yes, please.
Hi, Soraia, thank you so much for your presentation. I would like to ask one thing as I'm also working on acid amyprid detection in honey, and I've gone through a few of the papers and where I got an idea like neonicotinoids could be very harmful for the honeybees as well, and some of them can even eliminate the whole colonies. So I would like to know, did you keep in your mind while study the pesticides, like it could also have a very negative effect on honeybees as well? When if we are going to use such type of pesticides as a pest control.
I'm sorry, I didn't understand which pesticide you were talking about. I understand it was a neonicotinoid, but
Yeah, it's acetamiprid.
acetamiprid.
Yeah, and
So
like in some of the European countries, imidacloprid has already been banned.
yeah, I know.
So, did you keep in your mind, like in the future, like if we increase the use of the acetamiprid, then it could also affect the other pollinators like honeybee.
Yeah, sure. So you can see in our paper that the lethal dose for hornets is much lower than for honeybees. And here we are talking about using acetamiprid for injection, direct injection on the nests. So probably the honeybees are not coming to contact with them, but understand, and yeah, of course, is very all of pesticides using for pesticide injection, all of them are always dangerous for other pollinators. But here we saw that the lethal dose is lower for hornets than honeybees.
All
But
right,
yeah,
thank you
yeah,
so much.
so
It was
we
in my mind.
consider that. Thank you for your
Mm,
question.
thank you.
Thank you. So anybody else has any questions for Soraia? I think so we have, yeah, another on the chat. Probably, do you want me to? I will read it so everyone knows what we're talking about. So Christina also asked, wouldn't it be interesting to find a period of time for the hornet death that doesn't allow her to come out the nest again after intoxication? It's a time to be that is 24 hours. Cannot the hornet come out the nest with a pesticide and contaminate the environment, or even die outside instead of contaminating the nest?
So I can also answer a little bit to this question. We also have data for the first 4 hours after exposure. We don't publish it because in OECD is used to use, and for lethal dose is used to the 24 hours are more important. But yeah, in a practical context, it's always important to understand the real time, but depends on many factors. So yes, we have the time, the behavior and the mortality, and sometimes they are not death, but ecologically death. They are have present symptoms like, for example, moribunds or hyperactivity or paralyzation. That they are not dead, but they ecologically are dead. But yes, it's also very important, and we will take into account this question. It's a very interesting one. And I think I answer. I think I answered the question. Yeah.
Thank you, Soraya. We also have another person, Benjamin. Benjamin, yes, you raise your hand, but you don't have your microphone on.
My microphone is on now. Am I audible?
Okay.
Am I audible now?
Sorry? Yes. Yeah.
Okay,
Yes.
okay. Okay, thank you so much for this wonderful webinar. It was really insightful. So, I want to find out how does the environment enhance the bee predator relationship and the climate change? Does it have a way of enhancing the impact of predators on the bees and also in enhancing ecotoxicology? I just want to find out the relationship between the environment, climate change, and the impact of the bees and the bees and the
I'm sorry,
pollinators.
I can hear you very well. I'm not understanding the question. I'm really sorry. Marta, is only me or?
No, I'm also not hearing well.
Okay, I will type it on the chat box. Let me type it.
Okay, thank you very
Yes,
much.
let me-
yeah, that will be wonderful. Thank you.
Okay, so let me type it on the chat box. Thank you.
So I don't know if you want to say something about Christina also
Christina.
added something. Yeah.
Yes, Z method is another method that I didn't mention here in my presentation. It can be also called Trojan horses, like is when we put a pesticide on the thorax of the hornet and we let it fly for the nest. We don't know where the nest is, and well, the study I know a little bit about this. I'm not working on this type of methods. They are ecologically, it's hard to understand ecologically the impact. So, but yeah, I want to read more about it. I'm not putting in part. So, but thank you again, Christina, for your contribution. Yeah. And we will wait for another question from Benjamin, right?
Yes, just select him. Okay, so the question is up. How does climate change or the environment in age bee predators impact on bees and pollinators?
How does climate change or the environment enhance bee predators impact on bees pollinators? So, well, the adaptation of the Asian hornets in some parts of, I will talk about Portugal, that is where I'm studying more about. We know that in some places of Portugal, the climate changes makes the hibernation, the fertilized queen don't hibernate. They still have activeness for the whole year. And this is a huge impact on honeybees because it's a new way of life cycle that is not really from them. There is an adaptation from our environment and is very dangerous and needs to be studied. I don't know if this, I really don't know if this happens in other countries. I know that in Portugal is can happen, but not in all the country too. So just small regions with the specific climate conditions, but the climate change can improve this adaptation and not the contrary. So yeah, I think is very important to consider also the climate change. I don't know if was this kind of answer that Benjamin was hoping to hear. Thank you. Okay.
So I think, yeah, it was a good explanation. So just, I think we have time for one more question. If anyone wants to ask anything else, I think we're we're okay. And it was a really, really nice presentation, Soraia. Thank you so much.
Thank you very much.
So as I said before, this will be on YouTube. So we're going to share it. And if anyone has any questions or further questions, or even wants to make some collaboration with you in this manner, which is great. This is the type of things that we want. But congratulations on your work. Thank you for being here today. And thank you, everyone. So I guess we will now end this session and pay attention to our social media for the next webinar for the next month, and we'll share more news on this. Thank you all.
Thank you.